The periodic table is often a bit mysterious. We didn't quite capture it when we took Intro to Chemistry. So let's simplify it and look at it just as it's related to what goes on in the soil. We're going to simplify the definition of valence just to talk about the charge on the element that we're finding, the ionic state, and sometimes that charge is not just on the element, but on a compound of how that element connects with oxygen, particularly in the soil. So when we start on the left side, all of these have a +1 valence, so they're monovalent cations. If we go over to the far right, we have the noble gases, which have no charge. But that next column down is the our monovalent anions. They have a negative charge. And then we're not going to talk about the electrons and which shells they're in and all that kind of stuff. We're just going to simplify it again. So when we come to the second column from the left, we're looking at things that are divalent cations. They have a +2 charge. You do the same thing on the right side. Instead of cations now, we're still working with anions, and we have divalent anions. This next column from the right is kind of odd. These can exist at multiple valences, starting from acting like they're trivalent anions to acting like they're trivalent cations, depending on what compounds they're connecting with. So that one we have to be cautious about. We have to do some careful observation when we're looking at the compounds to determine the oxidation reduction status, how many electrons that nitrogen has with it. This next column, the one that we're interested in, is primarily carbon, although silicon can be a beneficial nutrient, as we'll see later. Carbon is the foundation for all the life that we know on this planet. So your carbon-based life form, things that are formed out of carbon, are organic beings, organic compounds. Now, if you're a sci-fi person, may remember that the shapeshifters are generally all silicon-based life forms, and you see it following underneath carbon in the periodic table. It just doesn't act the same, though, even though it should, based on the science. We have this column, +3, so they're acting like a trivalent cation. We have these in the middle. We call them transition metals, so they can exist also at multiple valences in the soil. Now let's talk about the nature of those cations. We have this group on the left. Those are the cations that tend to form bases in the soil, as opposed to these metals, which tend to form acidic or acids in the soil. So we have our basic cations and our acidic cations. Now, when we're thinking about the soil, the primary ones that we're concerned with are the sodium, magnesium, potassium, and calcium. Those are the ones that we find in the soil most commonly. Then if we think about nutrients that plants use, we've got these are our macronutrients, nutrients that are needed by plants in larger amounts. And the plants get the hydrogen, the oxygen, and the carbon from the air and water. So all these others they get from the soil. So we get nitrogen, phosphorus, sulfur, potassium, magnesium, and calcium. All of those nutrients the plants get from the soil. Then we have the micronutrients, those needed by plants in smaller amounts. We have the B-mine cousin monocle, with the addition of iron in there, the micronutrients. And then there are some elements that plants do not need to complete their life cycle, but that under certain conditions might be beneficial for them. For instance, cobalt is needed by the rhizobium and any other organism that has the dinitrogenase enzyme that helps fix atmospheric nitrogen into something the organism can use. These others, silicon, selenium, and sodium, can partially substitute if there's not a sufficient amount of, let's say, potassium or sulfur. That gives us a quick look at the periodic table as it applies to, and the elements in it as they apply specifically to soil and soil science.